So last week we ended somewhere here, and now we have demonstrated how to construct models using the software. Today we want to look at what we can do further. The last time I showed you the model, and in the model there was a mediator, right? The mediator was employee engagement or something like that. Yeah, behavioral engagement. Yes, this one. So today we can practice with that. We can see how we move ahead with mediation, right? So let's look at the slides. And so mediation analysis tests a hypothetical causal sequence in which an initial predictor influences a mediator variable. And in turn, the mediator influences an outcome variable. The analysis is used to explain the process through which the relationship operates. So when you look at this particular one, the first one on top, the diagram on top, you can see that we have a simple model here where there are two different constructs, the independent variable and then the dependent variable on the right. And always it is from the left to the right. Okay, we don't do it otherwise. We don't place the IV on the right side and then invert the arrow to the left. No. So this is the standard and the norm that we always observe. So in this simple model, there's no mediation. So once we introduce another variable, and that variable in turn explains the outcome variable, that variable becomes the mediator. So anytime there is a variable in between other construct or variable, we term that variable as a mediator. Okay, the mediator serves as the mechanism that carries the effect of the mediator's variable serves as the mechanism that carries the effects of the predictor to the outcome. And this allows the researchers to understand why or how the effect occurs rather than only whether it exists. Mediation analysis does not redefine the relationship between the predictor and the outcome. So the predictor is also known as the independent variable. Okay. Instead, it decomposes the total effect into direct and indirect. So the purpose of mediator here is it decomposes the relationship between the direct effects. So the direct effect always gives us the total effect. It decomposes it into direct and what indirect effects. Okay. And then to clarify the underlying causal pathways. So let's look at the mechanism. In mediation analysis, the total effect of a predictor on an outcome is separated into direct and indirect effects that operate through the mediator. This separation helps clarify how much of the relationship is explained by the intervening variable or the mediator. So in other words, if you don't hear mediator, you can also refer to it as what intervening variable. A mediation effect is established when the predictor significantly influences the mediator, and the mediator significantly influences the outcome, okay, which indicates that the mediator plays an active role in transmitting the effect. So this independent variable predicts that, so the movement is from IV to MV, and this in turn predicts that, okay, so that is what you are referring to here. And this shows that the mediation plays an active role between the direct models. In PLS-SEM, mediation is assessed using bootstrapping procedure to test the significance of the indirect effects, since indirect effects do not follow a normal sampling distribution. Okay, so just as we mentioned, to get the statistical significance, we always refer to the bootstrap. So this applies to this as well, mediation as well. Now let's look at the various types of mediation. We have what we call the full mediation. And this occurs when the relationship between the predictor and the outcome is completely explained by the mediator. such that the indirect effect becomes non-significant. Sorry, such that the direct effect becomes non-significant once the full mediator is included in the moderation. Okay. So we have the direct relationship here. Once we include the MV, the intervening variable, assuming that when we run the IV and DV, we have the relationship between the two to be significant. Now, once we introduce the MV, which is the mediator, if the relationship between this IV and DV becomes insignificant, and the relationship between the intervening variable and then the IV and DV becomes significant, such that, as already mentioned, IV and DV are not significant. It means that the MV here gives a full mediation. Okay, so that is the meaning of full mediation. If the MV is introduced and then it gives significant results or p-value, such that IV and DV is not significant, that means we term it as full mediation. Now, the second type of mediation is the partial mediation, and it occurs when the mediator explains parts of the relationship between the predictor and then the outcome while the direct effect remains significant. Okay, so the opposite of the number one is number two. Okay, and so now we have introduced our MV. In as much as we introduce MV, our relationship between IV and then DV is still significant. In that case, the MV explains only a partial causal relationship. Okay, it only explains partial mediation of the result because already the IV, in as much as we introduce the MV, the IV and then the DV is still significant. So in that case, we term it as partial mediation. And it can also happen that there will be no
Can I
mediation
ask a
at all.
question?
Okay, sir.
Yes, please. I want to get a full mediation. So the full mediation is in a situation where A and B is significant in the model, but the presence of envy make C not to be significant is a full mediation. Is that the understanding?
Okay, so if you say A and B, A here
I mean,
refers to,
no, I mean the coefficient. I mean, MV is like from IV to MV. MV is making IV to be significant. At the same time, MV is making the DV to be significant. But from the direct one, from IV to DV
which
is not
is right,
significant. That means there's a full mediation. Is that
which
it?
is the C. So if the C here, I hope you can see the C here.
Yes, yes,
So if the C here becomes insignificant and the
yes.
mediation variable, so in the mediation, we are going to see the reports. It's going to show like IV, then the arrow moves, then MV, then arrow moves. So it's always three. If the mediation is one, the relationship is that IV moving towards MV, moving towards DV. You're going to see that in the software very soon. And it's very clear, if it is mediation, you see that it is in between the relationship. So once the C, the coefficient of C is not significant, the p-value is not significant, it means that the mediation can be termed as full mediation. I hope that is right. Yes, so I was talking about no mediation. Yes, it can happen that there's no mediation observed. And that is when the indirect effect through the mediator is not significant, which shows that the mediator does not play a meaningful role in transmitting the effects. So these are the various three types that we can uh, observe whilst we are running our models. So mediation is supported when the indirect is statistically
Hello, sir.
significant. Okay, sir.
Please, I want you to go back to the previous slide. So for the full mediation, it's clear to me, but the two and the three, the partial, so the partial, still the C will be non-significant, then one will be significant for maybe, let's say, A may be significant and B may not. And what of the C? The number three.
Okay, so um, The C is the direct effect, right?
The
Do
D
you agree with
rather.
me?
Yeah.
Yes.
Yeah.
And A is also a direct effect because A is
Okay.
predicting MV. IV is predicting MV, and the coefficient is termed as A. Okay.
Okay.
Same way, MV is predicting
DV.
DV. And this is
Okay.
also another model, right? This is another direct model. So assuming that one thing you have to take note is that the mediation sometimes serves as an independent variable because if you're looking at the relationship between the MV and the DV, that is a direct model. In that case, our MV is what? Independent variable. Okay. So the A and the B here are all direct effects. But what we are referring to is that the relationship between IV and then, so let's take note that the mediation is not given any label as a letter here. I don't know if you understand.
Yeah.
So let's refer to as MV. So the A
Okay.
that you see here is not uh, the mediation. No, the A is the direct effect of IV and MV. The B is the direct effect of MV and DV. I hope
Yeah.
that is clear. Yes.
Yes,
So
please.
now, if the coefficient of the direct relationship, which is the IV, and then, so this is the main model, the IV and then the DV, right? If the
Yeah.
coefficient between
Yeah.
IV and then DV, because it is as a result of the IV and the DV, that's why we can have intervening variable. Okay, so we are not even referring to IV and MV or MV and then DV. We're referring to the direct relationship, which is IV and then DV. So
Okay.
if the relationship is significant and such
Okay.
that the intervening variable also gives us a significant p-value, that is why we term
Okay.
it as partial. Why? Because already the IV is explaining this significantly. So whatever this does is a partial explanation that is given to us. But if the IV and then the DV is not such that the MV gives a significant mediation, that is where we term it as full mediation
Okay.
because it is fully explaining the mediating rule.
Okay.
But if the direct itself is already playing the role, whatever the mediation does, it is what partial because already the direct ones are giving us the full explanation of our model.
All right.
Thank you very much.
So if I got it right, there are two types of uh relationships, like full and partial.
Yes, those are the two basic
Okay.
type of mediations. And so I
Okay.
added
So
another one, which it can also be that the mediation is not significant at all. In that case,
okay.
there is no mediation. So that's the third one I was referring
All
to.
right.
Yes,
All right, sir. Yeah. Thank you very much, sir.
yes. So
So in that case, how different is that from the direct?
in that case, how is the mediation different from the direct effect?
Yes. When the like the C- when the part three happens where the mediation is not significant at all.
Yeah, you have to explain why it is not significant. So with research, you expect to get significant output, right?
Yes.
So it means that the relationship that we are testing or what we got, what we wanted to explore, it is not statistically significant. Okay, so probably you have to investigate more into that. You can suggest, or you have to also discuss during the discussion session, explain why the relationship could not be mediated. All right. Mhm. So anytime there is a result, the fact that there's no significant people does not mean that don't report. No, it can even happen that the direct effects, some of them are not even significant. And that is what you got. You cannot change that. The purpose of research is not to get significant p-values. Okay. So leave it as it is and explain possibly why is it that the mediation is not significant. Possibly that particular variable is not meant to mediate, but possibly to have a direct relationship or even moderate. Okay. So you just have to discuss why the relationship is not the case. Is there another question?
So moderation and mediation, are they different?
Oh, yes. So from mediation, you're going to move on to moderation.
Okay.
I don't know how, so let's go ahead. So this is moderation, yes. So let's look at it. I think this was the last slide before the questions came in. The significance of the direct effect is then examined to determine whether the mediation is full or partial, with a non-significant direct effect indicating full mediation and then significant direct effect indicating what? Partial mediation. The strength of the mediation effect is assessed using variance accounted for, which indicates the proportion of the total effect that is explained by the indirect pathway. There are other softwares when you use it. For example, if you use SPSS, I think it gives you the variance accounted for, but the smart PLS does not really give you that. So with smart PLS, you just have to just go ahead with reporting your p-values and then explain why it is or not the case. Okay. But traditionally, the software gives us variance accounted for. So if you see that somewhere, don't be confused. And normally it is in percentages. Okay. I'm sure going forward, the software is still under development. So going forward, I'm sure they're going to add that. There are a lot of significant changes that keeps on happening once the software is updated. Okay, so now let's look at moderation. Moderation focuses on whether on when or under what conditions the relationship change. Okay. It examines whether the relationship between the predictor and then an outcome changes across different level of another variable. Moderation introduces a third variable that alters the strength or direction of the relationship between the predictor and then the outcome. The effect is not transmitted through this variable. So if the effect is not transmitted, that's where we term it as moderation. But if the effect is transmitted through the other variable, that is the mediation. So mediation is transmitted through another variable. But moderation does not do that. It only alters the relationship between the direct and then the indirect effects. The moderator does not explain the relationship. Let's take note of that. The moderator does not explain the relationship, but the mediator does that. Okay. It only influences the strength or the direction of the relationship. Moderation helps identify boundary conditions. So under what circumstance does this direct and indirect relationship occur? Okay. It shows when a relationship is stronger, weaker, or reversed under specific condition. In PLS-SEM, moderation is tested using the interaction effect. So this effect shows whether relationships differ across levels or contextual or individual factors. Okay, so let's see. Is there any question on the moderation so far? Okay, so let's proceed. Moderation are basically.
I want to make a plea. Please, last time I think I requested for the slides. When it's uploading a video like that, we cannot have actually time to examine the words. So
Okay.
you promised of sharing, but it was not shared. So I don't know whether today you'll be able to help us because we want to get a theory thing well grounded. Thank you.
Thank you very much. I'll do that. I think I traveled the next day when we ended the class. That's why. And where I am right now, the network is not really working for me. So
Okay,
today,
sir. Okay, sir.
yeah, even very lucky that it's working.
Okay, sir. Thank you.
But I'll try and then let me see. Oh, please remind me after the lesson so that I can share it on WeChat.
All right, sir.
Thank you very
Okay,
much.
sir. Thank you.
Okay, so we can also have two types of moderations. Okay, with regards to the variable types. So we can have categorical moderator and then continuous moderation or moderator. A categorical moderator is a variable with distinct group or categories. So we can moderate gender. So gender, we can have male and what? Female having a moderation effect. We can have culture B, culture A and culture B, ethnic group A, ethnic group B, ethnic group C, or whatever. We can have early stage or late stage group. And this can change the strength or the direction of the relationship between an independent variable, and then the dependent variable. Okay, so the first one is the categorical, where you group them into distinct categories or groups. Now, we also have the continuous moderation or moderator. And the continuous moderator is a variable measured on continuum. For example, we can have age in years. Okay, so maybe from the ages that we took, they are from 18 to maybe 35, 55. You can have tenure in month, satisfaction level, okay, on a scale of maybe 1 to 7. That strengthens, weakens, or reverse the relationship between the independent variable and then the dependent variable. Okay, so let's look at the key features of the categorical moderator. The moderator splits the data into subgroup. So we compare the path coefficient, that's the relationship between these groups, to see if they are significantly different. For example, is the relationship between X and Y the same for group 1 as it is for group 2? Okay, we are going to demonstrate that with the data that we have. So in research context, we can see that the impact of customer training, that is X, on customer loyalty, that is Y. Here, we can group them into B2B and then maybe business to customers. B2B is business to business, and then business to customers. So here, the moderation effect, we can interpret it as the relationship is strong. For example, business value training because it reduces what? Employee errors. So with business, you can say that if you run and you have a significant people or the interaction is significantly different from that of B2C, you can say that maybe business value training because it will help them to reduce what? The error that is made by employees. Okay, but the relationship can be very weak for business to customers because I don't think most of the times it happens that businesses will have to do training for customers. Okay, so individual consumers really use training and prioritize convenience or over instructions. So normally with business to customers, they always prioritize maybe customer satisfaction and all of that. So that is it. Now let's look at the continuous moderation or the moderator feature. So here we don't create any group or category. Okay, because normally it is in continuous form. It can be in a Likert scale. So we don't create group for those who selected maybe strongly disagree, strongly agree, no. We leave it as it is. So there's no group that exists for continuous moderation, moderator variable. Okay, so the moderator interacts with the predictor variable across its entire range. So if it is age, the age range, it interacts with it. And then we analyze this using the interaction term, that is the predictor, multiplied by the moderation or the moderator variable. So this one, the software does it. In other software like Stata or PLS, or SPSS, we have to create these variables. But with Smart PLS, you just have to establish the latent model. And once you do that, if you run it automatically, it creates this prediction for you by multiplying the predictor variable by to the moderator variable. Okay, so that is it. So these are some few examples. Thus, the effect of X and Y becomes stronger as the moderator increases. So we can have age range of from 18 to 75. Okay, that is the customer age. So you can see that the relationship is strong. For younger customers, the relationship can be very strong for younger customers. Why? Maybe they trust and engage with social media ads. So in a research context, for example, the impact of social media advertisements on purchase intention, we can moderate age to see whether the relationship between social media advertisement and purchases intention is altered by customer age. Okay, so if the relationship is very strong, okay, and then it's significant, you can see that maybe younger customers trust and engage with social media ads. Maybe for older customers, the relationship might be weak. such that you can say that they prefer traditional media and they are skeptical about social media. Okay, so age can have a weak or can weaken the direct relationship between impact of social media advertisement and then the purchases intention, depending on the sample that you dealt with, right? Now look at the diagram. This is a very simple diagram that explains mediation and moderation. In the model, mediations or mediators are variables that are always in between the construct, the other constructs. So once this is established, it is termed as mediator. In Smart PLS, for moderation, you just have to move you just have to connect your variable to the line. So if you want to moderate the relationship between the independent variable and then this one, you just have to move it, connect it to the line. That is all. So if this one too, you can move it and connect it to this one, and then that way. So that is it. You can demonstrate that on the software. So, but before that, is there any questions so far? Let me check. Okay, so there's no question on the chat box. So let's mediate business behavioral engagement. The last time when we displayed the model, we realized that the BE was a moderator. Okay, so BE, and we have so BE1, BE2, BE3, BE4, up to BE5. Just select that and then move it in the canvas. So we have here to be behavioral engagement. Good. So now, if this is mediating, it means that we have to reconnect our relationship, our lines. So now, you select connect, and then move this one to this. And then this will also come here. In that case, digital access and then academic outcome become a direct relationship. And then it is mediated by behavioral engagement. All right. So what I'm doing is that I want to move it to the center. So you just select, and then Control plus A. Control plus A will select everything for you. Or you can just highlight on it and it will select the entire model for you. So I've moved it into the middle, and then I will increase it small. So let me move it here. Good. So now let me connect the others. Good. So now this is the mediator. Now I can run it to see the results. Open to full reports. You can check, we just added a new construct, which is the mediator. So you have to check. You can also check it from here, as we said the last time. We have our house square to be 0.448, adjusted to be 0.45, 445. The reliability is met, it is more than 0.7. The AV is more than 0.5, alpha more than 0.7, and then the rho C also more than 0.7. So this has been met, right? Already we have done this before, and we met that. So we are good. You can check for VIF and see. So this is our VIF. Everything is less than 5. Okay, so we are good to go. And let's see if the relationship is significant. So how do you go? We go to the bootstrap. Bootstrap is where we get our significant p-values. And let me turn this on to faster. Because the last time we demonstrated that when you turn it to slower, it will take some time, but it will give you the full model or the full results. So let's give it to faster. And then let's start calculating so that we can be very clear with it. So now you have gotten our p-values. You have gotten our results. Let's expand this. The last I also made mention of that because we have included the path and then the p-value. That's why this is overlapping. Okay. So in that case, you're supposed to reposition these well so that they can be very visible. We cannot leave this overlap for the reviewers. No. So now let's go to the full report. But even with that, you can see the p-values here, 0 0.0, 0 0.0, 0 0.0. But let's go to the open full report. Now I have it here. So the path coefficient. So this is the direct relationship, right? And this is the estimate or the beta coefficient. So these are the direct relationship. So if you want to see the results for the mediation, you go to specific indirect effect. That is where the results are reported. Okay. So this is where I am. And we can see clearly from here, digital access is being mediated, or the relation between digital access and academic outcome is mediated by behavioral engagement. All right. Learning support and academic outcome is mediated by behavioral engagement. And let's see the p-value. The p-value is 0 0.00, 0 0.00. So here, is it full mediation or partial mediation? Mr. Johnson, that you
Full mediation.
really? Is there anybody who want to also try? Is it full mediation or partial mediation?
Between what and what? I mean,
Oh, you can just try. So probably let's
It's partial.
give it the first one. So
It's
digital
partial.
access and then the behavioral engagement. And then that of academic outcome. Is it full mediation or partial mediation?
Say it's partial.
Why is it partial?
Because there is significance between like for all the
Okay, so we saw that from here, right? The relation between digital access and academic outcome was significant at 0.00000. So less than 0.001. And then the indirect is also giving us significant p-value. So in that case, the mediation here, the behavioral engagement is what? Partially mediated, because already the direct effect is giving us a p what? Value, which is already significant. Is that right? So we can say that everything here is partially what? Mediated based on the data that we have. Okay. That is how it is. So this is partial mediation. So because we used the complete faster, that's why we don't have this R squared, the values here, that's why we don't have it. But if you use that, you're going to have these results. Okay, so that is mediation. Now let's go and moderate with another variable. So let's rerun again. Let me see, the last time I posted a module on the platform. So we have SD. SD is skills development. So let's say you want to moderate skill development. What do? You just select and don't forget what we are selecting, we can term it as a continuous moderation because it's on a scale of 1 to 5. Do you agree with that? Do we agree? Do we agree that when we moderate SD, which is skills development. If we moderate this one, do you agree that it is a continuous variable, moderator variable, or it is categorical? Hello, anybody want to try?
Come again, sir.
I'm saying that when do you agree that we are moderating this variable? When I do this, do you agree that it's a moderation that we are doing? So in the lessons, we said that moderation, we moderate, and on a model, what we do is that we move, so we connect the lines. Instead of the model, the construct, we connect it to the line. So what I'm
Yes.
doing here is a moderation.
Yeah.
And we discussed that we have two types of moderators, right?
Yeah.
And we said that it can be in the form of categorical moderation or continuous moderation. So what I'm doing right now is that we are moderating SD, which is also part of our data sets. And SD is on a scale of, SD is here, from here, 28 to 32. And you all agree that SD is in a form of continuous variable, right?
Yeah.
Thank you very much. So that was the question I was asking. So what I'm doing right now here, this is a moderation that I'm doing.
Okay.
So this moderation here is a continuous moderation. I can also moderate, let's say, gender. We want to see whether the relation between data access and, let's say, behavioral engagement is moderated by gender. Okay. In that case, I'll bring my model here and then press enter, and then I will link this one to that. In this case, it is what? Moderation. And this moderation here is categorical moderation because we have only two groups. We have male and what? Female. Thank you very much. So that was what I wanted to establish. So let me bring this one here. I can move this one to the left so that we can see, or move it down a bit. So this is gender. So let's run the model and see. So our first run algorithm, this is the results. And when I do that, I want to check whether this is meeting the criteria, right? Because this is a new model that I've added. So now we can first check from here. Our indicator loading are all above 0.7. So we are good to go, right? And let me move this one here so that you see the relationship clearly. Good. So, we have run the model and then we realize that, okay, this has met all the conditions, 0.7, 0.7. Our AV is above 0.5, so we are good to go. So now let's check whether the moderation is significant or not. So we go to Bootstrap, and then we start calculation. Good. So now you can see already we have selected our structural model is displaying both p-value and then the path coefficient. So whatever you see in brackets here is the p-value. Okay. So you can see that this is 0.95, 0.6, 0.0. I think they are not significant. Now let's go to the OP report and see that in full. So with moderation, you can find it in the path coefficient, but with the mediation, you come to specific indirect effect. All right, so this is the mediation. Okay, so now let's go to the moderation and check. Good. So now the path coefficient gives us the direct relationship, although we are moderating gender, but the software automatically also determines the direct effect of gender and then behavioral health engagement. But what we are interested in is actually the moderation rule. And whenever you see X, okay, it means that the gender is being moderated by the relationship between digital access and then behavioral engagement. So the X here means that the values in gender are being multiplied by the values in digital access. Okay, that's why. So anytime you see X, it means that, or times, it means that it is the moderation. And when you see this arrow here, the dash and then the greater than sign, that is the relationship or the path coefficient. Okay, so here we moderated the relationship between digital access and behavioral engagements. And that is, we use the gender as moderation, which is a categorical variable. And the p-value is 0.518. So this is not significant. Anytime you see red, it means that something is wrong somewhere. So here it is not what significant. Let's go to skills development moderation, which is moderating the relationship between behavioral engagement and then academic outcome. So here, the beta or the original sample mean O is negative. This means that it's reversed the relationship. Do you agree with me? You can recall that we established that um, we established that it shows when a relationship is stronger if it is positive for the direct and it is giving us positive, it can be stronger. So if you get the same thing, that is stronger. If it is negative and then it gives another negative sign, it means that it is weaker. So, and then if we have positive in the direct and then you get negative with the moderation, that is a reversed. So once we introduce a moderation, the outcome is a reversed outcome, right? So it reverses the circumstances. Okay. So now let's look at skills development and behavioral engagement. This is it. The outcome is positive, and let's give it significant. Yes, so skills development and then behavioral engagement was significant. Now, when we moderated that with now let's check this one too. That we want to look at digital access and then academic outcome. Or let's check this one. Let's check digital access and behavioral engagement. Digital access and behavioral engagement. The moderation is negative, right? Digital access and behavioral engagement. The moderation is negative coefficient. Now let's look at digital access and then that of behavioral engagement, the direct effects. The effect was positive. Okay. The direct effect of digital access and behavioral engagement was positive. Now, when we introduced the moderation, which is the skills development, the result says that it is what? Negative, right? So here, the moderation here is reversing the relationship between, it is changing the relationship between digital access and what? Academic outcome. Sorry, digital access and then behavioral engagement, which is this one. So this negative here is a reverse relationship. Okay, so assuming that here was also a positive relationship, you can see that it is what stronger. And if it is negative for the direct, and then also negative for the indirect, that is where you can say that it's what weakens it. Now let's check the p-value. So this is what this was not significant. So we cannot see that it is the case because already the p-value is not what significant. I don't know if there's any question so far on this. Any question? Now we have what we call simple slope analysis. Okay, the software also gives that. So how do you get that? You run your PLS algorithm, and then you start calculating, open full report, and we can find our simple slope analysis. So the simple slope analysis here in the PLS algorithm. Okay, and that gives us a graph. Okay, so now skill development and then learning outcome or learning support. Very good. And then the dependent or the outcome variable is the very. The lines here, if they are parallel, it means that there is no what mediation. All right, so you can see that this one is parallel, parallel, parallel. So there is no mediation in here. Let's check the other one. This is also parallel, parallel. You can see that this one is a little bit, this one is not parallel. Okay, this one is not parallel because this one becomes the green at one standard deviation at minus one standard deviation. The relationship between or the moderation rule of skills development between platform quality and then academic outcome becomes more steeper. Okay, it falls more. And this one tends to become positive at one standard plus one standard deviation. So you see, if it is moving from the left, from the right to the left, if it is moving this way, that is it becoming less steeper. So if it is falling, it is more steeper. Okay, it becomes steeper. If it is, I mean, becoming vertical, that is where it becomes less steeper. So the red means that at less than one standard deviation or negative one standard deviation below the mean, or at one standard deviation below the mean, it becomes flatter. Okay, and then the mean score or the mean moderation score is the blue one here. Okay, and then this one is at one standard deviation above the mean. So it means that at one standard deviation above the mean, it becomes less steeper or becomes more positive, right? And then if it is falling flatter, it means that at one standard deviation less or below the mean, it becomes more steeper, right? So this one is parallel. You cannot say that it is mediated. And this one, also parallel. This one is more likely to be. So this can go at a point and then interact. Okay. So that's why we don't have significant values. So here, this is gender, the categorical variable, right? Moderating data access and then behavioral engagement. So gender at 0, this is it, and then at 1, standard deviation, you're going to have it becoming less steeper, all right? So this is a simple slope analysis. Any question on this? Simple slope analysis. So you can report on these ones. And if this is what we use to determine moderation, sometimes it can interact. If it crosses, okay, if it crosses, you can report these in your analysis and explain as I have explained to you. The steeper and then the less steeper. We mentioned it, right? Any questions?
So please, can you go over that again? You said the more steeper it becomes, the more what?
Okay,
The more
so
interactive it.
no, what you are supposed to focus on is that Interaction happens when the lines are not parallel, right? When the lines are not what? Parallel. So you can see from here, this and that, this and that, they can never meet because it is parallel here. That's why the result given is insignificant p-values. Do you understand? You can see that they are not, there is no moderation at all. That's why you can see them to be parallel here. Okay, parallel, parallel, parallel. Okay, so this can at the point be given, but let's look at the result. What was the result? So let's go to bootstrap. Okay, so this one is also giving us 0.518. Okay, but let's take note of this. With categorical variables, they are in groups. So you can go further and determine, is there any significant difference between the groups? With gender, you can have both male and female, all right? In that case, what are you supposed to do? We have what you call bootstrap multi-group analysis. Bootstrap multi-group analysis. So let's try that, whether is going to work. Okay, good. But I'm not sure. Okay, have you already done this grouping before? This is showing here because probably you have done this before. I don't know if somebody recalls that. Yeah. Because if you have not done that, this will not appear. So let's see. Okay, singular matrix problem. All right. Okay, so sometimes you can see some of these issues. But let's see how we can resolve that. Let's go back to let me save it. And then let's go to the data set. Let's check whether we have created groups or not. So let's say data group. Okay, so it means that we have already done this. But for the purpose of those who have forgotten it, let's delete that. And then let's generate the groups again. So we can create group by adding it yourself manually. If we have multiple groups, for example, we can have different ethnic groups. So let's say we have maybe um, Ashantis, we have Fantis, we have Eres, we have other groupings. In that case, you can do it manually. Okay, so let's try and then do gender manually. So let's go to please choose. So you choose your indicator. Which one do you want to group? So it is the age that I want to group. So I can group age. So I select this one. And then I'll choose equal to. And then I'll choose a value. So I can say 1. All right. And then I will name this group. Let's say, because already my 1 is male. So let's assume that when you were coding your data during the cleaning stage, and then you assigned 1 for female, when you get here, you're supposed to also make it known. Okay, you cannot assign male during the cleaning stage and come and assign male as 2 when you did it as 1. So here, male is 1. That is why I've selected the value to be 1. So I'll just apply. All right. So I've created a first group. So it means that the male are only 144. And I can create another one as well and call it female or females. And then I'll select the age again. And I'll choose equal to. In this case, it's going to be 2, right? Because already 1 is what? Male. So we have about 181. Oh, I think something is wrong, right? I selected age. Let me edit it. So nobody saw that. So let's go look for gender. Gender. So gender, apply. Good. And then let's edit this one. Where is gender? Good. So gender, So this is it. Male and then female to be 231, 219 for females. So this is our first group. All right. And then what else? Is there any groupings that we can do? You can also generate from level of studies. So this is the manual way of going about it. Okay. So male, we added the group manually. You can also generate it automatically by using, let's say, level of, let's use age and let's group there and see. Also, it means that the age were in different, they were in about 5 groups, right? So I'll refer to the questionnaire and see how they were grouped. But let's assume that this is maybe, let's say, 15 to 20 years. Okay, this is undergraduate, so let's say 15 to 18. Okay, so these people are group 1. Then we can edit this one to 18 to um 18 to, let's say, 21. And then this one can be 21 to 25. 25 to 28. And then 20, let's say 29 and above. This is 22, right? Good. But this way is better. This way is better because if we make this one 25, if we label it as 25, it will not give us the accurate response, although it has already grouped them. But you're supposed to give it range. So 22 to 25. So if you make this one 25, it means that the people who are of age 25 can also be found in here. Although there's not going to be any change because already the groupings have been done by the software. But if you're labeling it, label it accurately so that you don't get it wrong. Okay. So that is it. We can generate more groups in here and we can even create a term. So for example, if you want to create a term, so for now, we're not going to do that. Let's go back. You have grouped our items and then now let's see. Now that we have the groupings, if you want to see whether gender moderates or does not moderate, what do? We normally use the bootstrap multi-group analysis. Okay. So now let's see. Let's say we want to see whether there's a significant difference between male and then female for this moderation. So let's calculate. All right. So this is happening because with multi-group analysis, when you are running it, you're not supposed to show this relationship on a diagram. So how do we do? Let's delete it. So one way you can delete it is that you click on delete and then you press on that, press on that. So now let's go and run again. Good. So now you see it has run. So let's kindly take note whenever you are determining the significance between a particular group, delete the model that shows the interaction. Otherwise, it's going to give you the singular matrix problem. So let's take note of that. So let's go to open report. So now let's see. We have our result in here. Now, is there any significant difference between male and female? Whenever you see, or whenever you have this is a positive relationship, and this is what's negative, negative, positive. Now, if you have positive outcome, it means that the male perform better than the female. That is why the result is what? Positive. If it is negative, it means that the female are perform better than what? The male. All right. So here is the difference. The difference is about which one is performing better or not. All right. And let's look at the p-value, 2 till none of them are what? Significant. So there's no significant difference among these two groups in terms of moderation. All right. So this is it. Um, okay, so normally we have these two groups. We have the parametric test and the non-parametric test. That is the Welch, whatever, substitute or whatever. It's somebody's name. And normally the parametric is used when we assume that there is no variance. Okay. But when we assume that variance exists between this group. But in social sciences, we normally use the Welch substitute test. And this assumes that there is no variance assumed between the two groups. So with social sciences, normally this is what we report on. All right. This is what normally we report on. So, and this is the confidence interval to determine whether there is the p-values are significant or not. So this is the multi-group analysis to determine whether there is significant difference between our moderation. Any question on this? Any question? All of these things are within the software, so they are not really something that we should be focused on. Okay. These ones are all the sample set. Any questions so far? Okay, so there's no question. That means we are all good. Okay. Let me rerun this again. So you can see that I deleted the moderation. So let me undo so that we can come back to where we started from. Okay. But once you are doing the multi-group analysis, remember to delete this moderation from here and then use the groupings. Okay. So that is it. That is what is very important. And you can now save or export your output. Okay. Just export it. They will ask you where you want to save it. Good. So I can save this one as moderation. Good. So this is it. Okay, so if there's no question, then we can move ahead with where we ended. The last time somebody asked about reflective versus formative indicators. Okay. So this is something that you're supposed to take notes. The relation between indicators and then the underlying construct can either be formative or reflective in nature. So the relationship between this construct and then the indicator, this ones, can either be formative or reflective. All right. So what we saw here, or what we have always been doing, is always reflective, right? Because the arrows are pointing towards the indicators. Latent constructs are assessed through observable indicators. The measurement model defines how these manifest indicators relate to a latent construct. In reflective models, the latent construct causes the indicators. So you can see that this moves towards that. So this causes that, this causes that. That is the causal relationship. Informative, the indicators causes define the construct, or changes in any indicator directly affect the construct itself. So that of formative, the case is different. The indicators are the ones that causes the construct. So you can see from here that this one is pointing towards that, and this one is pointing towards that. So this is the formative, and then this is the reflective, right? So here, changes in any of these indicators will not affect the data access. If this is reflective, I can delete one indicator, and this will not affect the underlying constructs. But with formative, okay, once we delete any of these, the underlying construct is not the same as it is, right? Reflective indicators are interchangeable and they share common themes, whilst formative indicators are unique and each contribute distinct meaning to the construct, okay? Let's look at the key distinctions. In reflective model, the data construct exists independently of its measure, okay? If one indicator is removed, the underlying construct remains intact, just as I demonstrated. Most skills in business research and methodological literature employ reflective approach to measurement. So in most cases, social sciences, where we use questionnaire, we mostly use the reflective, right? Because we set questions that are that are within the same theme, right? They are within the same themes. In informative models, the construct is entirely dependent upon the indicator chosen by the researcher. Okay, it reflects a constructive interpretation. Formative indicators cannot be dropped without changing the meaning of the construct, because each of the indicators have or has unique or contribute uniquely to form the construct. The direction of the causality differs. Reflective models assume constructive or the construct to indicators, whilst with the formative it is the otherwise. To indicators to what? The construct. So this is a typical example. And we used socio-economic status as example. The core component of socioeconomic status are formed by these three components. That is income, education, and occupation. All right. And once income is missing, if you are testing for education and occupation, you're not really testing for socioeconomic status, because that's the idea of socioeconomic status fundamentally does not exist without these three. So once one of these is missing, it means that you are looking at something different, not socioeconomic status. All right. Something like job satisfaction it is reflective. So
Frank,
yes, sir.
I'm sorry, I need to make an inquiry with the socio-economic status.
Mhm.
The parameters that we have, the income, education, and occupation. how are those parameters generated? Or you will have to put them there.
Oh, some of these things are already they are measured. You can find them even on World Bank, right? You can find these some of the, if you are dealing with secondary data, most of these measurements are there. So income, there are ways that incomes are, there are certain constructs or some of these things are already calculated and then available online. Socioeconomic status, something like Human Development Index. Most of these indexes are created, okay, but basically they are created as a result of these combinations. So any index that is created, it is as a result of specific contribution or outcomes that are the ones that form that. So let's assume that you are dealing with socioeconomic status. Once we combine income, education, and occupation together, we have to use um, the formative constructs. And this is what together forms what we call socioeconomic status. I don't know if you are good or do you still need clarification on that?
Yeah, I think it's okay, but I think the arrow we have at the top, the E3, so does
Well,
that presuppose?
The E3 is an error term. The E3
Okay.
is an error term, yes. So normally the error term, with research, there are always error terms, right? So the software does not show that, but it's always in there. That's why you have bias corrected and all of that. But I'm just demonstrating it here so that you can see that there is an error term in there. But the error term can be found within the construct. But with reflective models, the error terms can be found within the indicators. So it can be found in here. So you can just ignore these error terms because the software itself does not show that. So here, the error terms can be found in here.
Okay.
But
All right.
because with the formative, they come together to form that the error terms can be found within the construct. Right.
All right. Thank you.
So you can use any of these once you're able to justify the reason why you are using. Well, basically social sciences and the kind of questions that we ask. Most of the questions are correlated. They are within the same theme. In that case, we use the reflective. Mhm.
Hello, sir.
Hello, sir.
Yes, sir. So, in case I'm working on a primary data and I collect the data on income, education, and occupation from the field. So, with this case, does it still qualify to be formative if uh, I'm working on it?
So in case you are dealing with secondary data.
No, primary data from the field, and
Mhm.
I have my income data, education, occupation. So in this case, does it fall under the formative?
Once they come together to form this, once these three come together to form the socioeconomic status, then that is formative,
Oh, okay.
right? But
All right.
it will depend on your research objective. What is the idea? What do you want to achieve?
All right.
Why socioeconomic status? What is it affecting? All right.
All
So
right.
good. Did you get it? But you see,
Yeah.
income will be something like ordinal, right? And then um, education, education will be whether the person is within maybe primary, secondary, tertiary education. So this is also ordinal. And then occupation. Occupation is binary, right? Or nominal. Let me say nominal. Occupation is nominal because it is not in a particular category. And then so with primary data, some of this will fall under this. If you are collecting data on income, education, and occupation, should fall under the demographics. So it is better to use them as moderation or probably control variables. Is that right? Because somebody's occupation should fall under nominal. Nominal here means that there's no underlying category. So somebody will be a teacher, somebody can be a nurse, somebody can be a lecturer, a professor, maybe a driver or something like that. There's no category in there. There are different professions that we are talking about. So
Yeah.
these are nominal uh, data types.
Okay.
Yes, I don't know if you have joined one of the classes. They've dealt with data types in the SPSS class. They dealt with data types. So you have the nominal, you have the scale, you have the ordinal, and you have the binary as well. And when we started the class, we mentioned that with SEM, the software automatically detects that. So instead of scale in SPSS, we call it metrics. And if there are only two of them, of the indicators, it is binary. Okay. And if there is some kind of ranking among these variables, we call it as ordinal because there is a particular order. So when you have level of studies, we have level 100, level 200. Those in level 200 are above those in level 100. So there's some kind of order in there. So something like this, in fact, in social sciences or something, if you want to use formative, you should have strong reason for doing that. Otherwise, go for formative. Otherwise, go for reflective. All right.
All right. All right.
So looking at this index, if you're using secondary data, you can just collect the data on income, education, and occupation, and then you are good. Is that right? Well, some of these things are already measured out there. You can just find them. Something like this human development index, SDGs. We have a lot of SDG goals measurements out there, and it is as a result of different indicators that form that. Okay, something like life satisfaction, it is grouped under common themes. So we use reflective. So what do you use to determine? What do we use to determine whether we should use reflective and then formative? Aside theoretical justification, you can use what we call confirmatory tetrad analysis in the software, right? So you can deal with this and then we close for the day. Confirmatory tetrad analysis is a statistical method used to empirically test whether measurement is reflective or what formative. So a tetrad uses 4 indicators at a time. So whenever you are dealing with SEM, okay, you have to make sure that at least there is a minimum of 4 indicators. That is why you can perform confirmatory tetrad analysis. So with 3 indicators, it is not possible that way. Okay. So it assumes or it uses 4 indicators at a time. CTE examines, which is the same as the confirmatory tetrad analysis, examines the patterns of correlations among the 4 indicators, the tetrad, to determine if they share common underlying cause. So in reflective, all tetrads should vanish or should be equal to 0 because indicators are caused by the same latent construct and share common variance. In formative, the case is different. Tetrads do not vanish because each indicator contributes distinctively and did not share common cause. CTA provide empirical evidence to validate theoretical assumptions about the nature of the measurement model. So that's what we can use to determine statistically. So how does it work in the software? The test uses chi-square statistics to evaluate whether the observed tetrad values are significantly different from 0. If tetrad values are not significantly different from 0, this supports a reflective specification of the model. If tetrad are significantly different from 0, this indicates formative is more appropriate. Okay. And then CTA helps researchers avoid misspecification errors that can lead to biased parameter estimate and incorrect conclusion. So it means that if you don't perform this CTA, you can misspecify your model because the underlying reason for using formative or reflective are not the same. So if assuming you use reflective, meanwhile it's supposed to be formative, it means that whatever result that you get is bias. It can lead to bias estimation of outcome. Okay, that will lead to bias conclusion. this empirical test complement theoretical consideration. So the first reason to use formative or reflective is as a result of theoretical consideration or theoretical meaning. Okay, if there are theoretical opinions, just as we mentioned, theoretically, life satisfaction is something that is an abstract concept. So the best way is that you have to set questions, which are the measures to determine it. But before that, you have to operationalize how you are going to measure life satisfaction. Once we do that, we set the measures, the statement. Okay, so this is a theoretical reasoning why we see life satisfaction to have reflective meaning. So basically, use theoretical considerations. Otherwise, you can also use the software to determine that. And most of the times, it is reflective that gives the outcome. So if 0 is inside the confidence interval, the lower confidence interval adjusted, and CI, which is the upper confidence interval adjusted, it means that it is not significantly different from what 0. And therefore, you use reflective logic. So let's see this one. How do you run that? You just run calculate, then you come to confirmatory tetrad analysis. So ideally, when you start, aside your theoretical reasoning, this is one of the very first things you're supposed to have done. Check for confirmatory tetrad analysis. So you run that, and then calculate. So let's go to open full report. Good. So you can see the tetrad. So we have the combination, you have AO1, AO2, AO3, AO4, then it runs again, AO1, AO2, AO4. So it does that so many times. All right. So now let's look at the confidence interval, lower adjusted, and then upper adjusted. So you can see that this one starts, it's negative 0.0000, and then I think there are some figures out there, but it's not shown. So do we see 0 inside or not? No 0 inside. Do we see 0 inside or not? Hello?
Is
Zero.
it with respect to the data or
Respect
the
to
table?
the first tetrad is this one. And this is so what we discussed was that if 0 is inside the CI, the CI is so CI lower adjusted. And then if 0 is inside CI low adjusted, and then the confidence interval upper adjusted. And it means that it is not significantly different from what? 0. Therefore, reflective logic is not violated. So look at this one. Is it violated or not? So here, the reflective logic
It's
is
not
not what?
valid.
Violated.
It's
Thank
not
you very
valid.
much. The assumption so one thing we're supposed to take notice that we are not doing this calculation to assume or to be very confident that yes, we are supposed to use formative and not. No, we want to do this to see whether the assumptions of reflective are violated or what, not violated. So if you look at this one, you can see that 0 is between, right? So if 0 is inside, it means that reflective logic is not what? Violated, right? So here, reflective logic is not violated. Same way, let's look at the next one. You can see that significantly we have negative and then this negative and positive negative. So here, reflective logic is not what? Violated. Thank you very much. And here, the same way, But let's check something. I think
But I have
we
a
changed.
question.
Okay,
Yes, but the respective reflective construct are 5. But when you are running the tetra, it's only is it a mass that you only pick 4 or it's
no,
minimum of
the
4?
software does that
Because
for you. It combines them for you. So here it has done the calculation. So this one, you're not the one doing that. Okay, do you understand?
yeah, so that means when I want to do anything like this, I must make sure I have a minimum of 4.
Very good,
A
because
minimum
the
of 4.
software combines four. So if it is less than four, it will not run.
Okay, okay.
Thank you. But what I even just remembered was that when we were explaining, I think I inverted one of them. So you have to revert it. So it means that whenever you are determining whether to use reflective or not, everything has to be in what? Reflective. So the core idea about the CTA is to check whether the assumptions or the core idea of CTA is violated or not, right? So now I've inverted it again. Let's do the calculations and open for report. So now let's check again. So this one we have 0 inside, so the reflective is not violated. We can also use the p-values to determine that. Okay, but basically we use the confidence interval because if the p-values are not significant, yes, that is where we can say that. Or if significant number of the p-values are not significant, you can say that yes, the reflective assumption is not violated. Okay, but basically the low adjusted and then the CI upper adjusted is what we use to determine. So let's check for this one as well. The same way. So reflective. All right. This one too, the same thing. Reflective. So this is how we determine whether to use reflective model or formative model. So PhD, if you are a PhD um, student and then you want to deal with SPS, my PLS, it is better to report all of these values. Okay, because PhD is a whole lot of work. So it is good to report on these values and then you can better justify your choices, not just doing anything without justification. Okay, so I will just pause here and
So here, when you're reporting, things, here when you're reporting, you have to show all the values or just the CI lower.
when you're reporting, you can just present on the estimate, the t value, and then the p values as well as the confidence interval, lower adjusted and upper adjusted. All right. So you report on what you want to interpret. Okay. For robustness and for confidence in your output, it is better to also add other aspect because once you report on um, this one and that one, there is also a relationship between that and then the p-value that you report on, right? And then there's also a relationship between that and the t-statistics. Okay, there's a relationship between t-statistics and then p-value. So there's a range. If it is above 2 points, I think 2.1 or something like that, you can find out for yourself. And normally, if it's above that, it's a certain threshold, either 1.96 or something like that. That's where you get your p-values to be significant. But if it is within this range, so you can see that this is 0.7. It is between 1.9 and then negative 1.9, something like that. That's why you have p-value to be 0.47. So you can report on them, but note that there are some kind of relationship between these values because they do not operate in isolation. The same way applies to, for instance, if you are dealing with Fonolaka, the score for the Fonolaka is the square root of the ABE. So if you change the values and then you leave others like that, it means that you are doing something that it was not based on the software's calculation. And that should not happen. All right. So that is it. So let's keep on practicing. So far, what you have done, I think you should be able to do some models. So along the week, you can get a concept, and then let's see how you can, go about it. If you have data as well, and you want to work on publication, that is good. You can discuss that later, and you see how best you can put this into practices and then in publications. All right. So today's class will be paused for now.
Okay, so please don't forget to share the
Yes,
slide
sir.
with us.
Thank you very much.
Okay.
I'll do that as
Thank
soon
you
as
so
possible.
much. Grateful.